Hello class 8 boys. In today's video we will discuss factorizing of an algebraic expression by using algebraic identities. Before this we have already learned factorizing of an algebraic expression already by two different methods. If we are to revise, let us quickly recapitulate that. The first method was by taking common factor. Okay, by taking common factor. The second method was by grouping of terms and then taking the common factor. Now today we will learn how to factorize an algebraic expression by using algebraic identities. Okay, now algebraic identities I believe is not something new for you. We have already discussed algebraic identities when we were dealing the previous chapter. Okay, so just to quickly revise, okay, I'll just write down the algebraic identities which we'll be needing in this exercise and which we have already done in the previous classes. Okay, so let us see what are the algebraic identities we'll be needing for this exercise. Okay, now let us go for the first algebraic identity. The first algebraic identity, as we know, is a plus b whole square is equal to a square plus b square plus 2ab. This can also be written as a square plus 2ab plus b square. Okay, the writing position, it really doesn't matter. Okay, a square plus 2ab plus b square or a square plus b square plus 2ab. So this was the first algebraic identity which we learned. Okay, now the second algebraic identity which we learned was a minus b whole square is equal to a square plus b square minus 2ab. Okay, which can also be written as a square minus 2ab plus b square. Okay, and the third algebraic identity which we have already discussed is a square minus b square is equal to a plus b multiplied by a minus b. Okay, so these are the three algebraic identities we'll be using in this particular exercise. Okay, today we'll solve a few questions from exercise 11.3 wherein we'll learn how to factorize by using algebraic identities, and these are the three algebraic identities which we'll be using today. Okay, now without delaying, let us discuss the first question and the application of these algebraic identities to factorize. Okay, so I'll go to exercise 11.3, which is on page number 217. Okay, I'll take question number 1 Roman 1. Okay, question number 1 Roman 1. Now what does the question read as? The question reads, factorize the following expression using the algebraic identities. Factorize the following expressions using the algebraic identities. And our first question, Roman 1, is x square minus 12x plus 36. Okay, just looking at the question, we can conclude that this should be in the form of a minus b. Why? Because we have a minus here, we have a plus here, we have a plus here, and we have a minus here. So we have a plus here, we have a plus here, and we have a minus here. So this should come in the form of a minus b whole square. Okay, but we cannot write it directly. We need to break this, we need to write this in such a form so that algebraic identities can be used directly. Okay, let us see how do we do it. Okay, the first term is already in the form of square. Okay, we leave the second term for the time being. We come to the third term, the last term of this algebraic expression. So the third term of the algebraic expression is 36. So we know what is 36. 36 is nothing but a 6 square. Okay, so we have got the a square, we have got the b square. Now we need to get the minus 2ab. So no problem with the minus, we have a minus here also, no problem. Already we have a minus, so minus comes here. Now we need to write the 2 into what is our a is x, into what is our b is 6. Okay, now let us check whether whatever we have written, does this satisfy the question or not. X square, fair enough. 6 square, 36, fair enough. Now the middle term, so we need to get 12x minus 12x. So we have a minus here. Now 2 into x is 2x. 2x into 6 will give us 12x. Okay, so we have not made any changes here. We have just tried to express this question in the form of an algebraic identity: a square minus 2ab plus b square, a square minus 2ab plus b square. Okay, so what does this mean? So this is in the formula for a minus b whole square. What is our a? X. And what is our b? Our b is 6. So see, a square minus 2ab plus b square. Okay, so this entire thing is in the form of a minus b whole square. What I mean to say, the x becomes our a, and what becomes our b? 6 becomes our b. So this is in the form of a square minus 2ab plus b square. So this can be written as x minus 6 whole square, a minus b whole square. That means x minus 6 whole square. This can further be written as x minus 6 multiplied by x minus 6. Okay, so x minus 6 whole square means x minus 6 multiplied by x minus 6. So this will be the factor of the equation expression x square minus 12x plus 36. Okay, so our main primary target is to write the question in such a way so that it either falls in the category of a square minus 2ab plus b square, or in the category of a square plus 2ab plus b square, so that we can express this in the form of a plus b whole square or a minus b whole square. Okay, so our final answer, our factors will be x minus 6 multiplied by x minus 6. Okay, now similarly question numbers 1 Roman 2 and 1 Roman 3 are similar to this, so that I'll leave it up to you. Okay, so question number 1 Roman 2 and question number 1 Roman 3, that will be your assignment for today. Okay, so I'll jot down the assignments at the end of the video. Question number 1 Roman 2 and 1 Roman 3 is done exactly in the same way. Okay, so you have to express it in the form of either a minus b whole square or in the form of a plus b whole square. It's done exactly in the same way. Okay, now let us move on to the next type of question. Now we have seen the application of a plus b whole square, a minus b whole square. Now let us see the application of a square minus b square, the third algebraic identity, which is a square minus b square. Okay, now let us pick up a question for this. Let's take question number 2 Roman 1. Question number 2 Roman 1 from the same exercise 11.3. Okay, the question reads as: factorize the following expressions. Factorize the following expressions. Okay, so the first question given to us is 4p square minus 9. Okay, 4p square minus 9. So we have only two terms here, and that two squares are involved. That means we should think that it should be in the form of a square minus b square. Okay, well, this question is not directly given in the form of a square minus b square. We need to convert, we need to write this in such a form so that it gives us, it is in the form of a square minus b square. Let us see. Okay, it's quite simple. Okay, 4, we know what is 4 in terms of a square. 4 can be written as 2 square, and already we have the p square, minus, now 9 can be written as 3 square. Okay, now if we just look at the first term here, 2 square p square, here also we have a square, here also we have a square. So can we write a bracket, and can we give a single square to both? 2p square. Is this and this the same thing? Yes, both are the same thing, they mean the same thing. That means this square is for the 2 also, this square is for the p also. So 4 can be written as 2 square, p square is already there, minus, and then 9 can be written as 3 square. Now 2 square p square can be written as 2p whole square minus 3 square. Now this is directly in the form of a square minus b square. Okay, so what is our a? In place of a, what do we have? 2p, and in place of b, what do we have? We have 3. So this is in the form of a square minus b square. A square minus b square is equal to a plus b into a minus b. So a plus b, that means a plus b multiplied by a minus b. So this will be our factors for 4p square minus 9. So we have to write it in such a way so that this comes in the form of a square minus b square. Okay, now to make things more clear, let us take one more example. Okay, So I would take an example wherein fractions are involved. Okay, so I'll take question number 2 Roman 2. Okay, so let us try to solve question number sorry, not 2 Roman 2. 2 Roman 2 is similar to 2 Roman 1, so I'll give that as your assignment. Let us take question number 3 Roman 2. Okay, let us take question number 3 Roman 2. So the question is 16x square minus 1 upon 144. 16x square minus 1 upon 144. Okay, now x square is already there and 16, so how can we write 16 as? 16 can be expressed as 4 square. So instead of the 16 we write 4 square. The x square is already there, minus 1 can be written as 1 square, no problem with that, and 144 can be written as 12 square. Okay, so what will this give us? So 4 square x square can be written as 4x whole square minus 1 square divided by 12 square can be written as 1 upon 12 whole square. Okay, so now if you see, this is in the form of a square minus b square, so we can easily apply the algebraic identity a square minus b square is equal to a plus b into a minus b. Okay, so let us turn the page and let us write down the final answer. So what is our a? So our a would be 4x a plus b, okay, multiplied by a minus b. So this will be our factor for the algebraic expression 16x square minus 144, a plus b multiplied by a minus b. Okay, now in these questions you must have noticed one thing, that the a square and the b square is directly or indirectly given to us. Okay, we just need to express in terms of square. Now what happens if it is not given in the form of square? That means the first term is also not a perfect square, the second term is also not a perfect square. Now how do we solve these type of questions? Okay, so let us take one example and solve it. Okay, I'll take question number 4 Roman 1. I will take question number 4 Roman 1. Okay, the question is 20x square minus 45y square. Okay, if we notice here, if we see here, x square y square, fine, no problem, but what about the numerical? 20, is it a perfect square? No. 45, is it a perfect square? No. But in the previous questions, what did we have? The numerical was also a perfect square and the variable was also a perfect square. But in this particular question we see only the variable is the perfect square, but the numerical is not a perfect square. Okay, so our target is to convert the numerical also to perfect square. Okay, now let us see how do we go about it. Okay, now what will happen if we take 5 common in here? Okay, 20 we can take 5 common here, 45 also we can take 5 common here. Okay, so let us take 5 common and see what will we get. So if we take a 5 common here, so what will be left over inside inside the bracket? 5 4s are 20 x square minus 5 9s are 45 y square. Okay, if I multiply back the 5 inside the bracket, will I get back the same question? Yes, we will. 5 4s are 20 x square minus 5 9s are 45 y square. Okay, so if we just take 5 common, after taking 5 common, our problem is solved. That means we get both the terms in the form of a square minus b square. Well, we have not got the terms in the form of a square minus b square yet, but it is in a form wherein we can express it in the form of a square minus b square. Okay, let us see how. So we'll keep the 5 outside. Okay, now 4 can be written as 2 square, x square is already there, minus 9 can be written as 3 square, and the y square is already there. Okay, so this is equal to 5. Okay, 2 square x square can be written as 2x whole square. Okay, 2x whole square and 2 square x square means the same thing, minus 3 square y square can be written as 3y whole square. Okay, now this is in the form of a square minus b square. Now we simply apply the algebraic identity a square minus b square is equal to a plus b into a minus b. So this will give us a plus b multiplied by a minus b. Okay, so this would be our factors 5 into 2x plus 3y into 2x minus 3y. So these are the factors for 20x square minus 45y square. So in this question, what did we learn? If the first term and the second term is not given in the form of square, perfect square directly, by taking common, we can convert both the term, the first term and the second term, in terms of a perfect square. And once we get in the terms of perfect square, from there we just need to express in the form of a square minus b square and just apply the identity a square minus b square is equal to a plus b multiplied by a minus b. Okay, question number 4 Roman 2 is similar to question number 4 Roman 1, so I'll leave it up to you. Okay, now let us take one more example from exercise, the same exercise, question number 5 Roman 1. Okay, so I'll take one more exercise, question number 5 Roman 1, one more question from the same exercise 5 Roman 1. The question reads as 2a plus 3b whole square minus 16c square. Okay, the question, it appears that is very big and complicated, but actually it is not. Okay, so we consider this whole thing as the first term, minus 16 is already a perfect square and c square is already given in the perfect square form. Okay, so how will we rewrite this? This can be rewritten as 2a plus 3b whole square minus 16 means 4 square and c square is already given. So this is equal to 2a plus 3b whole square minus 4 square c square means 4c whole square. Now this is in the form of a square minus b square. So what is a square minus b square? A square, this entire thing is our a and this is our b. So what is a square minus b square? This is a plus b multiplied by a minus b. Okay, a plus b multiplied by a minus b. So 2a plus 3b plus 4c multiplied by 2a plus 3b minus 4c will be the factors for 2a plus 3b whole square minus 16c square. Okay, so this is the way you factorize algebraic expression wherein brackets are involved. You don't get confused. Try to treat this whole, the first bracket, if it's given in a square, perfect, it's already given in the square form, no need to get confused. So treat the whole thing as a square minus, try to convert this in the form of b square. Okay, so b square. So this is how this is factorized. Okay, now based on these workings, I will give you a few questions as the assignment. Okay, these questions are done exactly in the same way as we have discussed in this tutorial. While you are solving the question, if you have any doubt, always you can go back and watch the tutorial once again, take help from the tutorial and solve it. Okay, moreover, whenever we are having our online classes, if you have any doubt, you can raise your doubts during the online class and I'll be more than happy to clear your doubts. Okay, so for now I will quickly write down your assignment for today. Okay, your assignment for today would be question number 1 Roman 2 and 1 Roman 3. These both the questions are quite similar to question number 1 Roman 1, which I solved right in the beginning. Then question number 2 Roman 2, question number 3 Roman 1, question number 4 Roman 2, and question number 5 Roman 2. Okay, so this won't take more than half an hour for you all to solve it. Okay, because just you need to apply the algebraic identity and just write it in the form of a square minus b square, or try to break it in the form of a plus b whole square or a minus b whole square. Okay, so these questions will be your assignment for today. So these questions are from exercise 11.3, exercise 11.3, which is on page number 217. Okay, so I hope this tutorial was helpful to you. If you have any doubt, please clear your doubts when we are having our online classes. Okay, and any more doubts, you can always WhatsApp me your queries. I'll be happy to help you with your queries. Okay, bye for now, take care.